Okay, this is Math 2. We're going to do 40, 41, 42 in Chapter 10. And it says using focus directrix graph paper, or I'm actually just using normal graph paper. So if you don't have graph paper right now in front of you, can you please pause the video and go get some? Because the rest of this is actually going to be all done on graph paper. So I'm going to be counting, I'm going to be maneuvering, I'm going to be measuring. So please stop the video and go get graph paper. Okay. It says sketch a parabola that has a horizontal directrix that is 6 units below the focus. With the focus being at 0, 0, you can get focus directrix paper. I don't want you to get focus directrix paper. I just want you to go get graph paper. And it says write an expression for the distance of the focus to any point x, y on the parabola. Write an expression for the distance from the focus to any directrix x, y on the parabola from the directrix. Those two should be easy to do. And then part C, I'm going to take a little bit of a different approach to actually solving it. It's actually my belief that it's kind of easier to do, but A and B should be pretty easy to at least visualize. So we're going to work this out. So I have some graph paper here. I drew the directrix, right? And if you weren't in our class, this is what we call the wall. So this was the wall. And technically the equation for this is y equals -6, right? And then the focus person, depending on what period you were at, everybody had to be as far away from this person as they were from the wall. This is our focus at 0, 0. And then, lo and behold, somebody jumped right in between because somebody figured out that, hey, I can stand right in between, right in the middle between the focus person and the wall, and I could be the same distance from both from the focus and the wall. So this is going to be our vertex. And if this is the wall and that's our focus person, we were obviously not going into the wall. We were going to go away from the wall, and we were going to create a parabola that goes off in both directions. So for the most part, I think we were successful in trying to figure out what the equation was for this, but we do have to answer part A and B, and parts A and B are actually what make this work so well. What it says is write an expression for the distance from the focus to any point x, y on the parabola. So let's say you didn't know how to count, but you did know that, hey, you know, somewhere over here, I'm going to be as far away from the focus as I am from the wall. But right now it doesn't look like it, but that's not the point of this part right now. But what you should realize is that if I wanted to really find the distance of how far away I was from the focus person to myself, then instead of, remember, I think a couple of us actually counted some steps. We don't know, but I do know that in order for me to find the distance, I do have to have a sort of a straight line that connects the two. And in order for me to actually figure out what the length is between those two, I really should know this point. And if I could find that point, then, well, what's to stop me from actually maybe creating a triangle? I could technically, on the coordinate scale, find the distance between any 2 points by creating a right triangle, figuring out what the value is of this leg, figuring out the value of that leg, and then using Pythagorean theorem to calculate the distance between the two. But since this is a really weird point, all I know is I'm going to go up a value of y, because the up and down is my values of y, and I'm going to go to the right a distance x. I don't know what it is. I'm not going to assume that it's exactly at, 6, 7, 7.5. I don't know. But I do know that I could figure out this length here by using these two pieces of information. So if I actually did have numbers on them, then I can just say, okay, this number squared plus this number squared is equal to your hypotenuse squared. So let's call this the hypotenuse, because that's really what it is. Then I would say, okay, well, x squared plus my y squared is equal to my hypotenuse squared. Okay, well, in order to solve for the hypotenuse, then you would, calculate the numbers out, and then you would take the square root of both sides. Well, I'm going to do that really fast, right? I'm going to say, oh, okay, well, let's say I did that. Then the hypotenuse is really the square root of x squared plus y squared. So if I wanted to, I could replace the word hypotenuse with x squared plus y squared. All right. And there's a reason I'm doing this in pencil, because after all this, I'm going to start to erase a little bit, because I do actually want to find the equation of the parabola. So x squared plus y squared is going to be actually the length between any point on this parabola and the focal point right there. And then I look here and I say, okay, well, I don't know what this is, and it's going to be kind of difficult to judge how far this is. But there is some pieces of information that we do have for judging distance between any point on the parabola to the wall, or the line of directrix, or the directrix, I should say. I do know that it's 6 down from the focal point. So I do know the distance from here to here is 6. Distance is always positive. I'm counting 1, 2, 3, 4, 5, 6. Distance is 6. And then I've gone up the same distance from this line, the x-axis, to this point right here, which I was using for my triangle. The same distance that I've gone up is the same distance on one of the legs of the triangle here. So I really have gone up a distance of y, because it's pretty much the same point. So technically, overall, my distance from this point to here is the addition of the 6 plus this y. So I've gone up a distance of y plus 6, or I've gone down a distance of y plus 6. Okay, well, if technically I've gone the same distance here, oops, I forgot to put the square on there. My bad. I've gone the same distance here as I have here, then technically this hypotenuse and this distance here should be the same, no matter what point on the parabola. If I go up, if I get closer to the vertex. So to set that up, it would look something like this. Well, this distance is equal to this distance, so that would mean that y plus 6 has to be the same distance as here, so that would be x squared plus y squared. So those two are the same, right? Okay, well that works out. But this looks a little icky, so I'm going to square both sides, because that'll get rid of the square root. So I have y plus 6 squared is equal to x squared plus y squared. Okay, so this is the expression for this equation. Now, that looks super messy. To me, it does. There are, obviously, it's there. You can use it. You can work it out. You can multiply this y plus 6 out and get your equation. But there are actually much easier ways to do this, especially since you're on a coordinate system. So we're going to use that method, because, again, this is just a little too ugly. So I'm going to erase this. So if you haven't copied this down, just press pause, because everything is going away right now. Everything in pencil, anyways, is going away. Okay, so this is how we're going to do this. We're going to do this how we did it in class now. Oh, for part C. So A and B, we're in there, basically. And then the next part is going to be how we did it in class. Okay, so you had to be the same distance from the focus as you were from the wall. So let's see, from here to here is a distance of 6. So I know if I can go out 6, I should be the same distance here. So I'm going to go out 6, right, which lands me over here, and then this is 6. So I know this is going to be 6, I know this is going to be 6, and it's symmetric on the other side, so I know this other point is here. There's the vertex, because it's right in the middle between the focal person and the wall. And now my parabola is going to go through here, and then it's going to come up in this direction. Okay, now we're going to use those 2 points, or in this case, we're going to use the vertex, and we're going to use the second point that we found to write an equation. Our vertex was, what is this? It's at -3, comma 0, and our point, this new point that we found, and I'm going to use the positive of this one, is at 6, comma 0, because it's still on the x-axis. All right, 6, comma 0. All right, so we have our general equation, y equals a times x. The vertex is at negative. Wait, did I do that right? Wow, I did that So horrible. I'm so sorry. 0 and -3. Wow, that was bad. Holy moly, that was bad. Okay. And then 0, -3, and then 6 and 0. Whoa. Okay. So x, the vertex is at 0, so it's just going to be -0. And then squared, right? I should do this in black so you can actually see it. So y equals x minus 0 squared. And then it's -3. We went down 3, so it's going to be -3, right? And then in the next step, I'm going to substitute the 6 and the 0. So this is x, this is y. Y is going to be 0 equals, still trying to solve for a. X is 6. Oopsie. Okay, and then -0 squared minus 3. So 0 is equal to a. 6 minus 0 is just 6 squared minus 3. So 0 is equal to 36a minus 3. So I'm going to add 3 to both sides. So I get 3 equals 36a. And then we have divide by 36, divide by 36. So we have a is equal to 3 over 36 simplifies into 1 over 12. Yay! Okay, so our final result is, let's see, y equals 1 over 12, x, vertex is 0, 3, x minus 0 squared minus 3, and to clean it up even one more time, it's just x squared minus 3. So I'll take both of those, as long as you understand that you don't really need a 0 in the next one, but there you go. So that was 40, and that was at 11 minutes. So I think I'm going to stop with this one here and then pull up the next two on the next section.